Hey, remote honors biology. Man, I try whenever I can to record class instead of recording a separate video for you so you feel like you're there. But didn't work out today. I recorded the whole thing. It was a good one. Sound failed to record, so that's a bummer. But I'll do something separate for you if it's too fast for you, because I do tend to talk faster when I'm not waiting for people to write in front of me. If you're having trouble catching up, just press pause. That's what the pause button's for. So here we go. See if I can get this going. We are talking about carbohydrates today. Quick review that our naming conventions, when it's just carbon and hydrogen with no double bonds, we are looking at something called an ane. If it's one carbon long, we use the prefix meth, 2 carbons is S, 3 carbons is prop, and 4 is bute. And then we talked about functional groups yesterday, about how these groups of atoms, when they're there on a carbon chain, they give it certain properties and certain names, like the hydroxyl group that makes alcohols, the carboxyl group that makes organic acids, and the amino group that makes amines. Side group that we won't talk nearly as much about is the carbonyl group that makes ketones, and that's where we left it. And that, by the way, is where you can expect to leave it for tomorrow's quiz, which on this first quiz, I am going to announce when it is so that you know when it will drop. From here on out, after this quiz that's tomorrow, I'll just be dropping them in when I drop them, and they'll be timed, and you'll have a certain amount of time to take them. But tomorrow, just so we get it all straight, tomorrow I'm going to have you all come to a mandatory meet that is very short. It's just at 1:45, and I'll post it, but a 1:45 meet to get you into a program called GradeCam, to give you your student IDs for that so that you can take the first quiz. Okay, so have that on your radar, and I'll post it. All right, the notes today. First, these larger carbon-containing molecules than the ones we talked about yesterday, the ones that you're made of, are called organic macromolecules. They're big, much bigger than just, prop or bute, like 4 or 5 carbons long. We're talking many, many, many carbons long usually. And the 4 major groups we'll talk about: carbohydrates, which include sugars and starches, which you're familiar with, I think. And then cellulose, a little different. That's a polysaccharide that makes plants crunchy. It's what's in their cell walls. And chitin, which is what makes insects crunchy. It's what's in their exoskeletons. Lipids, which include fats and oils, which should be familiar to you, but less familiar maybe phospholipids, which are components of your cell membranes, and some hormones. The hormones that aren't lipids are proteins. Proteins are these long chains of amino acids. That's what makes them proteins, that they are composed of amino acids, and you'll learn how to draw those in a couple days. But so the ones that are the right shape when they fold up to make chemical reactions happen, those are enzymes. The ones that hold living things together are called structural proteins, for example, collagen in your skin. And then the rest of the ones, like we said, that aren't, rest of the hormones that aren't lipids are proteins. The one we won't talk about much at all this chapter, because we have 2 full chapters devoted to them in third quarter, are the nucleic acids, called nucleic because they exist mostly in the nucleus. The informational molecule that is DNA, that's deoxyribonucleic acid, and RNA, which is a less, sort of informational, also sort of a workhorse code transfer and protein builder. So those are the 4. The one we're going to look at in detail today and tomorrow is carbohydrates. What makes carbohydrates is a little different from the other 3. It's pretty easy to spot the other 3. This one, it's all about the ratio of carbon to hydrogen to oxygen. And if you notice, 1 to 2 to 1, one way to remember this is by the name carbohydrate. Carbo, of course, as in carbon. You think of that 1 carbon in the ratio. But then hydrate doesn't mean hydrogen. Hydrate means, if you think of it in everyday language, it means to drink water, right? So if you think of carbon and water, well, water is what? H2O. So the carbon and then H2O, that's a 1 to 2 to 1 ratio. So if that helps, you remember that ratio. Use that. Now, to get a sense of that ratio, let's just look at the single sugars, which we call monosaccharides. And you may or may not know the simplest sugar that the sugar that your cells use to get energy. They're kind of built around getting it, which is called glucose. I think you've probably seen glucose before. And I want to just, if you don't know it already, show you the formula for glucose. If you don't remember, it's C6H12O6. And you can see that's a 1 to 2 to 1 ratio. If we reduce it like we do with ratios, divide by 6, you get 1 here and 2 here and 1 here. So hopefully that makes sense. Fructose and galactose. Fructose is also known as fruit sugar, and galactose, it doesn't happen a whole lot in nature, but all three of those, here's the thing, all three of those monosaccharides, same molecular formula. Molecular formula is just the number and type of atoms in it, and when molecules like that exist, we call them isomers. Isomers, same molecular formula, different structural formulas. And I want to show you how that's possible down here real quick. This is the structural formula of glucose. Now, one thing that might confuse you a little bit, I've talked about how organic chemists tend to be lazy. First of all, right, we leave out things like the bond between O and H here in the hydroxyl group, but we talked about that already. The one we didn't is that there's so many carbons in organic molecules that sometimes they just leave them out. And everybody knows when there's an angle like this, that's a carbon. That's a carbon. Oh, that's a terrible C, sorry. That's a carbon. That's a carbon. And that's a carbon. And so you can see C, 1, 2, 3, 4, 5, 6 C's, right? 1, 2, 3, 4, 5, 6 O's. And you'll just have to trust me that there's 6 H's. I'm not counting them. But here's the thing with isomers like that, like glucose and galactose, man, blink and you'll miss it, right? Here's the difference. It's just that one OH is up in galactose and down in glucose. That's the only difference. And so when you get into your virtual molecular modeling kit that I'll post the link to, or maybe I already have, you'll be able to see when you build glucose, which you will need to do and take a screenshot and send it to me. When you build glucose tomorrow, you'll be able to see that you can't change that. Once that ring is locked, once you've closed the ring of carbons and oxygens, these don't flip, right? So if it's up, it's up. And what makes it glucose is that the OH groups go down, up, down, down. And you can't just bend that and convert it into galactose. They're separate molecules. Anyway, the next important thing is when you put two monosaccharides together to make a disaccharide. And a disaccharide is just a covalently bonded pair of monosaccharides, and there's 3 of those that you'll need to know. And they are when you put glucose and fructose together, which is sucrose, and that is basically what we call real sugar, right? As opposed to fake sugar, we call it real sugar. It's just usually cane sugar, or we call it table sugar. Its real name is sucrose. 2 glucoses bonded together are maltose, which that's a sugar that plants pack into their seeds so that their little embryo offspring have enough energy to get to the point where they can start photosynthesizing themselves, right? And so humans are very good at extracting that sugar by soaking it in the right temperature water, and we make stuff with it. One of the things you've probably had that tastes like maltose, it's a very distinctive taste, is Whoppers candy, the candy that comes in a milk carton, the stuff on the inside. Now the outside's chocolate, but the inside is that malt sugar, maltose, and that's got a very distinctive taste that's different from chocolate. Also a frosty malt, if you've had one of those. And finally, glucose bonded to galactose makes lactose, which is milk sugar, which, whether you know it or not, most mammals on Earth, which includes most humans on Earth, though they able to digest lactose with an enzyme called lactase early in their lives, because of course that's what makes us mammals, is we drink mother's milk, right? We're able to digest that lactose. Most humans on Earth, most mammals on Earth, lose the ability to digest milk later in life. We stop drinking milk, so we stop making lactase, and that makes most humans on Earth lactose intolerant. Now, the West is kind of an exception. Europe, Western Europe, and the United States, we keep drinking milk. A lot of us keep drinking milk throughout our lives, and so we keep the ability to break it down. But people who don't, the only difference is they just have to watch when they eat dairy. If they eat dairy, it can give them what we will politely call intestinal distress, if you know what I mean. Now, take a guess at what the molecular formula of each of these disaccharides is, because they are isomers. They do have the same formula. Now, if your guess was to just double C6H12O6 and say C12H24O12, you're very close. And the only reason you didn't get it exactly right is because I haven't taught you about how those two monosaccharides come together in a disaccharide. The process is basically that these sugars are all full. Their electrons are all spoken for. They don't have anywhere to bond. So you have to pull something off of them. And what it turns out you have to pull off is the OH from one of them and the H from the OH of the other. And what you get pulling those things off is, of course, water. It's an ugly looking water, too. No, that's not water. That should be a hydrogen. Sorry. Yeah, and because you're pulling out water to free up the bonds for those two things to get joined, the process is called dehydration synthesis. Okay, bonding molecules together by pulling off an H and an OH from each molecule respectively to free up the bonds for them to join. And so because you're pulling a water out, it's C12H22 instead of 24 and O11 instead of O12 because we pulled out the H2 from here. Oh, this is very tiny. And the O from here, where it would have been 24, now it's 22, or it would have been 12, now it's 11. Hopefully that makes sense. So, monosaccharides and disaccharides and dehydration synthesis. That's kind of the main message of the day. Tomorrow, you'll get to play with them a little bit with your molecular modeling virtual kit. Don't forget the mandatory Google Meet tomorrow at 1:45 to get your GradeCam login codes. And from then till the next day, you'll have a quiz to take, just so you know that's coming. Okay? All right. Hope this was okay. I know it's not the same as being in class. Oh, by the way, one more thing. I know I said that we might be doing some live streaming. I am finding that that's probably not going to be practical. It's just, you know, a 40-minute class is I think a little much, and there's enough downtime in those that I think I would lose you at times as far as your attention and all that. So I like kind of being able to pick my spots and show you what I want to show you. Always feel free to have Google Meets with me. If you request one, we will find a time for us to meet, and I'll always have at least one mandatory meet and one optional meet during each week. Okay? Hope you're having a good Tuesday. See you later, remote learners.